This question is to solve logarithmic quadratic inequalities. Please subscribe to our YouTube channel Math Tutor 8285. Your subscription fuels the passion. Thank you so much. Let me be a positive real number. Consider the inequality in the variable x. The expression consisting of the square of the logarithm base 3 of m minus the logarithm base 3 of the quantity 27 times m squared, all multiplied by x squared, then minus the quantity logarithm base 3 of m minus 3 multiplied by x, and finally minus 1, is less than 0. For which values of m is this inequality true for every real value of x? There are 4 options. First step, we rewrite the coefficient of x squared. We first simplify the complicated coefficient. The square of the logarithm base 3 of m minus the logarithm base 3 of the quantity 27 times m squared can be rewritten as follows. It is equal to the logarithm base 3 of m minus 3 multiplied by the logarithm base 3 of m plus 1. So the inequality becomes the quantity logarithm base 3 of m minus 3 times the quantity logarithm base 3 of m plus 1 multiplied by x squared, then minus the quantity logarithm base 3 of m minus 3 multiplied by x, and finally minus 1, is less than 0. To make a quadratic expression negative for every real x, its leading coefficient must be negative, and its discriminant must also be negative. Next step, examine when the leading coefficient becomes 0. The leading coefficient is 0 when either the logarithm base 3 of m equals 3, or when the logarithm base 3 of m equals negative 1. That corresponds to m equals 27, or m equals 1/3. Now, test each case. When m equals 27, the inequality reduces to simply negative 1 is less than 0, which is always true. So m equals 27 is acceptable. When m equals 1/3, the inequality becomes 4 times x minus 1 is less than 0, which is not true for all x. So that value of m must be excluded. Then, next step, solve the general case when the leading coefficient is not 0. For the inequality to hold for every real number x, 2 conditions must both be true. First, the leading coefficient, which is the product of the logarithm base 3 of m minus 3 and the logarithm base 3 of m plus 1, must be negative. Second, the discriminant of the quadratic, which is the square of the logarithm base 3 of m minus 3 plus 4 times the product of the logarithm base 3 of m minus 3 and the logarithm base 3 of m plus 1, must also be negative. Solving these 2 conditions together gives that m must be strictly between 1 divided by the 5th root of 3 and 27. After that, next step, combine the general solution with the special case. From step 3, m must lie strictly between 1 divided by the 5th root of 3 and 27. From step 2, m equals 27 is also acceptable, but m equals 1/3 is not. Therefore, combining everything, the complete set of all valid values of m is the interval starting at 1 divided by the 5th root of 3, including this endpoint, and extending up to 27, but not including 27. This matches option B. Final answer is option B. That's it for this question solving. This video is based on our math tutoring blog and class recordings. Please subscribe to our channel Math Tutor 8285 and turn on the notification bell. Press the like button. Your subscription fuels the passion. Let's grow together. Thank you so much.